Hi, this week we talk about in Chapter 6 graphics, digital media, and multimedia. This should be something you're all very familiar with. So, what we want to do today is kind of explain some of the differences and the nuances between painting software, image processing software, drawing software, and 3D modeling. And 3D modeling, as you know, is a precursor to going into the 3D printer because you can't really print without doing the 3D modeling. Anyhow, so some of those events. Techniques for improving the quality of our presentations and slides, and the use of digital technology in video and audio, how data compression works, and this is probably something you all know, and some future uses of applications. So everybody knows about the web. Tim Berners-Lee, he created the web moons ago, and the reason he created it was that he was looking for a way to be able to share papers across people in academia. And so it was a method to be able to hyperlink papers together, that just providing this link, you would be able to access a paper, kind of like what we do when we do research and we go to the library. And this actually started the whole concept of the web. And the web, we're not going to go into all of the different components of it, but the web is not old. The web, he invented it in the 1980s. So that whole, getting this whole virtual web type of presence going, made us really think about how do we put information out there on the web. And there's several factors that determine that. First of all, we could put as much as we want on a server, but it all depends upon how fast our connections are to the server to be able to determine if you can get it back. And that, as we have gotten faster protocols with, Verizon and with cable, and eventually it's going to be satellite. As those things become more robust and be able to take greater quantities of data in a single packet, that will change the way we're able to store data and access it. So when we first started, everything was just a text. But now we're able to actually go to pictures. Pictures is now everywhere. And pictures are nothing more but what we call pixels, which are tiny dots of colors that make up an image or of a screen. Even though the pictures have become more complicated and more refined, it's still a matter of how compressed those pixels are to be able to create the picture. So painting software is simply being able to create pixels on a screen that's interactive, and moving those lines and whatever the images on your screen, and using the different colors. And the colors have increased as the computers have increased in sophistication. Originally, we could only do about 255 colors, but now there's an infinite amount of colors that we can use because of just the ability of our processors to be able to handle greater amounts of color. And that actually was greatly impacted by gaming industry. As the gaming industry demanded or required greater access of colors and graphics to be able to do what it does, the computers had to respond to that. So it was very much a mutual process. And as the number of chips on a processor could increase, that made a huge difference too. So as the chips became smaller and the number of processors on a chip, you could put more of them because they became so condensed, that enhanced the ability for greater graphics, greater movements, all of those, and greater data communication. Imaging processing, Adobe Photoshop is one. I'm using something called Captivate as I create these videos. I can then go into these movies that I create. I can add header and trailer slides in the back of them. I could add some animation to them. Last week, as you notice, I tried to blur out my email on something. I could add photos if I want. All of those are different types. Adobe Photoshop is a perfect example. Everybody's seen pictures of somebody's head on somebody else's body. It's quite interesting. So drawing softwares is something also very interesting. We use it for actually creating architectural software, landscape design software, any kind of furniture creation software. Mechanical engineers, electrical engineers all use different types of vector-driven graphics to be able to create what they want to do. Okay, so PDF. PDF, we all know about PDFs. It's a file format that it's pretty ubiquitous to the types of operating systems. That's what makes it nice. They can be linkable, which makes them very portable, and they can contain all kind of images and graphics, and they can be protected, which is one of the things that makes them most useful in academia. Bit mapping gives you the advantages of more control over textures and painting, and object-oriented drawing, which has become very popular. Clearer, cleaner lines. Remember, there was a time when we would have like little jagged edges around our perimeter of graphics and pictures and even letters, but that has really become quite refined as we've progressed. So some interesting programs that we would want to talk about contain both painting and modules. Even PowerPoint has become more sophisticated if you think about what can be done there. So choosing the right tool for the right job, this is always the same thing. We need, as we continue to, as our technology increases, we really should be looking to see how do we improve the quality of our presentations. I've sort of demanded that in this class by looking at how do we integrate graphics, movies, other types of media into a single project at the end. And we want to continue to grow that. Animation, integrating animation into a project. But there are some things that you need to know. Don't borrow without permission. Understand the copyright. And you can take something from the web, especially if it says you can take it, but oftentimes it'll just say it wants to have acknowledgement of who produced it. So Creative Commons is a great place to go where you can share your work with others and they let them use it as long as they acknowledge you. And you can take things that other people have created and integrate it into your own work. 3D modeling software, as I talked about before, and we even had it with our presentation on healthcare, we talk about how 3D modeling software, first of all, helps us to be able to see the dimensions. Think about going in for an MRI, for example. An MRI looks at the body, looks at the ligaments, it looks at the tendons, the nerve endings, the bones, and it creates an image for the radiologist to be able to look at. The same is true as we're looking at 3D printers. We have to use a 3D modeling software to create that picture of the chair with all of the dimensions and then be able to feed that into the 3D printer software to be able to produce that particular product. We have some software here, and we have a 3D printer here at Marymount. We have several of them. They're used in the science programs, they're used in the interior design programs, and I think that it's really interesting to see how they're going to be used in healthcare more and more to have quick and easy, different kinds of arms and legs and hands and all types of appendages that really fit the specifications of the patient. CAM and CAD, they've been used for a long time by architects to be able to design buildings, design rooms, design all types of things. They can test prototypes. And the sophistication of them, once again, has really improved based upon the fact that the number of chips, the number of processors that can go on a chip have increased. So, the chip is the one piece, and there's processors on each of the chips. Well, as the processors get smaller, we're able to put more of them on to have greater impact while still keeping the size small, which I find to be most interesting. That's how come the phones, for example, have gotten to be so much smaller. I mean, the phone today has more processing power than the computer did, 20 years ago. So, making powerful presentations using art. Picture is worth 1,000 words. Make sure you test it before you present it. This is a real problem. And if you test it on your computer, that's one thing because you have all the files resident in your computer. You really need to test it on somebody else's computer. Don't read the slides, so hopefully I'm not doing that. And look at all of the, use bullets and use numbers and things to be able to point out what you're trying to say. There's this whole philosophy that you should not have more than 5 words on a slide and that there should be pictures. And the picture should be able to say what it is you want to say. To really do presentations, it's knowing your material. So if you have a picture and you know your material, you don't need all those words. Dynamic beyond the printed page, and I think we've pretty much talked about this: animation, video, audio, using your thing, all the different components within your computer. Formats, all the different formats that we need to know. Digital video cameras, capture footage. These are all things that you already know fairly well. We all went through the process of where our TVs went from analog to digital, and so our TVs either required to have a converter box to take the digital signal, turn it to analog. But this whole process of how we are just slowly going from tape, from the old time tapes, cartridge tapes for video recorders, to just digital, is all part of a continuing evolution of where we're heading with a storing of data. So remember, the reason all these changes can occur is because the way we're able to store and access data is changing. Digital. So you know all these things. Storyboard. Now I think this is an important piece to talk about. Whether you're doing a presentation, whether you're doing a short movie, whether you're doing just you're creating a web page, for example, you want to be able to do what we call a storyboard. And a storyboard is actually kind of talking about what's going to happen in this, what is the intention, and how are you going to create it, and what are the different kind of attributes you're going to use, whether it's pictures, music, video, something like that. Storyboard is very popular if you're creating games. You have to be able to identify what the animation is going to be, what are the characters going to look like, how are they going to interact, because all of those have to go into the design of each of those individual characters that you create, actually. And video production, I am very fond of using YouTube. As a matter of fact, I use it for everything because it's ubiquitous. I don't care if you're on your PC, on a tablet, on a Mac, on your phone, on your iPhone. I don't care, because the YouTube protocol is ubiquitous to all those devices, and it will work on all of the different browsers. Because remember, every browser doesn't work exactly alike. So what might work with Mozilla may not work with Safari. I had an incident of that today with Canvas, for example. So that's something to consider. Data compression. That this is an interesting concept. So we have become highly sophisticated in our ability to use our cameras, our high-powered camera equipment, our cameras meaning our phones. That's what I meant. Our phones to be able to take pictures, our cameras, and they're lots of pixels. Well, guess what? All of those pixels cannot be stored up into the cloud. They're too difficult to access. And you always have to be thinking about your audience when you're creating anything digital. How are they going to access it, and where are they located? And do they have access to high-speed connectivity? If you're going to be creating things that are going to go to people stationed overseas, for example, you want to make sure that you're not creating high digital content with lots of pixels, because they're not going to be able to access it. It'll be so slow. And remember, there's a rule that anything that's taking longer than 10 seconds, the user has already clicked out of. So knowing how to compress that data is very important. And there are softwares that can take your very sophisticated high pixel count pictures and then convert them to web-enabled digital images. Okay, so here, this is talking about music. And we all are aware of how music has changed. Sometimes I wonder if the musicians actually sing anymore, because there's so much modification with synthesizers, sequencers, digital improvement, background voices that aren't even there, that they probably could even make me sound good. So digital, I remember when the digital piano became very popular and people could just put in a disc and they would be able to play. Well, now baby grand pianos can take that same process, and you have like a disc. You put the disc into the piano plays itself, like the old time player piano. So digital do's and don'ts. These are the formats, and you can look at these in your own time. But you want to stick with standard type of formats that are going to be easy for any web enablement. MP4 is very popular. MOV is very popular. They go with all types of systems. WAV files, hypertext, hypermedia. We use that all the time. Help files. Just-in-time training is a perfect example of using hypertext type of things, where you just say, I want to do, and then there's a list of possible options, and you just click on the one you want. That's actually how the business world is doing training, by just-in-time training. All right, so this is something in the book that you can go through. Authoring software, Adobe Flash is something that, sometimes I think it's annoying when you get that little, you're looking at a website and all of a sudden something comes into your website with like a lot of movement and like a fireworks or something. It can be distracting, so you have to be careful how you use it and when you use it, and is it adding to what you're trying to accomplish, or is it distracting? So one of the things that I did want to talk about before we end are visions of the future. What type of multimedia can we expect? So I read today that Sports Illustrated swimsuit issue is now in a virtual reality format, and you can buy for some small amount of money the virtual reality app, which would include the swimsuit model in some kind of a setting doing something. So the impact of virtual reality is going to become greater and greater as we are able to have the ability to put this very high pixel type of pictures on the web, and B, that the technology becomes more sophisticated. So virtual reality, augmented reality, these are some of the topics we discussed last week. They're very important, and I hope that you will look at the chapter to get a better sense of what those applications might be. Just imagine going to George Washington's house, and as you're taking the tour, they give you augmented reality glasses, and you're taken into, as you go in to look at a particular room, you see a setting of a party going on, and you can see actually the people there at the party doing things and the foods and actual movement, and you feel like you're part of that event. That's where we're heading in terms of augmented and virtual reality. Shared spaces. So we've kind of covered a lot of ground. Some of it I think that you've known, but the two components that I really want to make sure that we bring home would be the impact of virtual and augmented reality into where we're heading, and how that's dependent upon our processors, the sophistication of our processors, our data compression, and our